All right, so in this video, I'm going to um, the review 4.5 superposition principle. So I'm going to solve the one a couple of examples, and then if we have time, then I'm going to cover 4.6. Okay, so what's the superposition principle? In the superposition principle says that the two can you say that here? Right. Okay. So to think about two differential non-homogeneous differential equations, a y dou prime plus by prime plus cy is equal to f of 1 of x, and then give me a second. This is superposition principle review 4.5. Superposition. Okay. So think about two non-homogeneous differential equations: a y dou prime plus by prime plus c. Here, left hand side equals each other. Okay, but the source functions are different. Okay, and then so let's say their solution functions are y1 of x and then y2 of x. Okay. All right. And then, okay. Then the a solution of this differential equation, y prime plus cy is equal to f1x plus f2. The solution of this differential equation, look at the right-hand side, are the f1 plus f2, right? Then the solution of that differential equation must be c1, let's say y is equal to, let's say y is equal to c1 y1 plus c2 y2. Okay, that's a superposition principle. So we applied this the theorem into the initial variable problem of non-homogeneous differential equation. How we apply this? So the let's say for given integral problem, say a y dou prime plus by prime plus cy is equal to f of x. That's what we have, you know, been dealing with the that differential equation is what we have dealing with. So here we want to find out. Okay, so let me give initial conditions. Let's say y of 0 is equal to, let's say, oh, sorry, let's say, I don't know, okay, a, okay, and then y prime over 0 is equal to b, right there. So then apply the superposition principle to figure out the particular solution of this integral problem. Then we need to figure out the general solution, right? So the general solution, let's say yg of x. Okay, this is the integral problem. Okay, the general solution is going to be y p of x, which is yp doesn't mean the particular solution of the integral problem. So yp means a solution. Okay, we can find out a solution using the method of undetermined coefficient, right? So yp of x is a solution of this non-homogeneous differential equation. and then plus YH of X. Here, Y of A, so this is a solution. Okay, a solution of the non-homogeneous differential equation. And the YH, this is the general solution. Okay, general solution to the associated general solution associated homogeneous differential equation. Okay, so so how, I mean, you may wonder that how we could get this, form this general solution by applying the superposition principle. I mean, how we apply the superposition principle to get this form of general solution, because we consider the f of x as f of x plus 0. Okay, so then from this by the superposition principle, we may think that we can split out this differential equation as the two non-homogeneous differential equations: a y dot prime plus by prime plus cy equals f of x, excuse me, and a y dot prime plus by prime plus cy equals 0. So we're going to have two non-homogeneous differential equations, and then applying the superposition principle, then we're going to get this result. So that's what we did last time, and then we saw one example of this this one, and then we'll see on other examples. Okay, so this example, y dot prime minus y is equal to 2t. Give me a second. And the e to the t, e to the t, right? And then plus e to the t, right? And then initial conditions are given is like this: y of 0, 1, y prime 0 is equal to 0. All right, so then what are you gonna do? Then step 1 in solution. Step 1, yeah, we're gonna find out the general solution to the associated homogeneous equations. Okay, so which means that I'm gonna find YH of x. Okay, y here, the independent variable is t, right? Sorry. So now then, what are you gonna do? We gotta find out Ox equation, right? So by the way, the we want to solve this: y dot prime minus y is equal to 0. This is the associated homogeneous equation, right? So then Ox equation gonna be what, r squared minus 1 equals 0, right? Okay. So now, yep. Then so r is equal to plus minus 1, right? So these are simple root, right? Okay. So y h of t is going to be what? C1 times e to the t plus C2 times e to the negative t, is it? Okay. So now next one, we're gonna find out what, and then yp, right? Once we find out yh, and then what are you gonna do? We gotta find out yp. Okay. So then step 2, find yp. right? So to find the YP, I told you we have to apply the method of undetermined coefficient. Okay. So then 2t, by the way, then we have to figure out the type of what? Type of the functions in the source function. So as you can see that the source function is 2t times e to t plus e to t, which means that this is equal to 2t plus 1 times e to the t, isn't it? So 2t plus 1 is a polynomial function, and e to t is an exponential function, right? Okay. So now then, yp of t is equal to t to the s, because we need this term in case of that, what? The, in case of that, we're gonna get the, what? I mean, we need a t to the s power. We need this term to avoid the case that this particular solution becomes the solution of the associated homogeneous equation. Okay, so that's why we need this term. And then you see that here, right here? I mean, let me write down the source function is the 2t plus 1 and the e to t, right? So you see, e to t, 2t plus 1, this is a polynomial with degree 1, right? So we, the particular solution should be involved in what? Polynomial with degree 1. So a1 t plus a0, okay? And the exponential term right there, yeah, so we need that term too, okay? Now we figure out a1, a0s, okay? So I know. So when I cover the 4.4, the method of undetermined coefficient, I did write down the general form of the solution, which is the, remember, the t to the s power and then a m t to the m's power plus to the a0. Oops. And then e to the rt, and then we figure out the m, r, and s, right? Okay. So we figure out parameters. Yeah, but I just skip um, a couple of processes to find the m and r. Okay. So, but this is kind of obvious, right? Because m must be 1. Why? Because degree of 2t plus 1 is 1. And the r must be 1. Why? Because the coefficient of t in a source function is 1, right? Okay. So now, so I skip to find the m and r in here. Okay. So now the s, we figure out letter s, right? So to find out the what, we need to compare what the coefficient t in a particular solution with what, the root of the auxiliary equation plus minus 1. If the coefficient t in a particular solution matched with the one of I mean simple root, then what, s must be 1, right? So, but you can see that the what, the coefficient t in a particular solution matched with the what, a simple root 1, then s must be 1. Right? So since r is plus minus 1, so s equals 1, we can say that, right? So the yp of t is equal to t times a1 t plus a0 and the e to the t, okay, which means this is equal to what, a1 t squared plus a0 t times e to the t. Okay. Then we find that yp prime. Why? Because what, we have to plug in yp into the non-homogeneous differential equation to figure out on determine the coefficient a1 and a0. Okay, So we need to figure out yp prime, yp dot prime. Okay. So this yp prime gonna be, yeah, I skip. Let me skip the how to find the derivative yp and the second derivative yp. Okay, this is just algebra. So a1 t squared plus 2a1 plus a0, and then t plus a0, the e to t. Okay, and then yp dot prime t is equal to a1 t squared plus 4a1 plus a0 t, and then plus 2a1 plus 2a0, and the e to the t. Okay, so now then the plug in yp prime, yp dot prime into the what? To the differential equation y dot prime minus now yp, that is equal to 4a1 minus t, 4a1 t, and then plus 2a1 plus 2a0, and then e to the t. Okay, so that must be equal to what? That must be equal to source function, which is a 2t plus 1 and the e to the t. Is it? Okay. So now, yeah, then what we're going to do, we just compare the each like terms, okay? By the way, e to the t, e to the t cancel them out, we can say that. And then 4a1 must be equal to 2, and then constant term 2a1 plus 2a0 must be 1. It means that a1 must be 1 half, and then a0 must be 0, okay? So 4a1 must be equals 2, and then 2a1, 2a1 plus 2a0 must be equal to 0. Then what? A1 must be 1 half, and then a0 must be 0. Okay, so we determine the unknown coefficients. Now step 3. Okay, step 3. Yeah, we combine YH and YP and impose initial conditions. Okay, so combine YH, T, and YP of T. Okay, so and impose initial condition. Uh, okay, so then Y T, I mean general motion Y is T is equal to Y H, oh, I'm sorry, YH of T plus YP, or we can say YP plus YH, okay? So now this is equal to C1 e to the T plus C2 e to the negative T, right? Plus 1 half T squared and the e to the T, okay? You may just confuse, well, with the statement in a superposition principle. In fact, in the superposition principle says that C y is equal to C1 y1 plus C2 y2. If you look at this, then do we have to put C1 and C2 in here? Okay, so can you say just C1 YH plus C2 YP? But you know what? You don't have to, because YH already include the unknown, the constant in a relation C1 and C2. Okay, so don't do that. So we need to figure out C1, C2, then we need to impose initial conditions, Y0 and Y prime 0, right? So now then Y0, what was, okay, let me write down Y. So now I mean, this is the what? This is general solution of the non-homogeneous differential equation, the problem. Okay, now we're gonna find out real particular solution of the integral problem. Okay, so the y of t is equal to what? C1 e to the t, right, minus c2 e to the negative t, and then plus t times e to the oh, 1/2, right? 1/2 plus, I'm sorry, plus 1/2 t squared e to the t. I'm sorry. Then the y. Let me find the y prime first, because eventually we need to figure out y prime in order to impose the second initial condition, the y prime 0 equals 0. Okay, so y prime t is a c1 e to the t, the minus c2 times e to the negative t, okay, and the plus t times e to the t plus 1/2 t squared e to the t, okay. Now we plug in 0 into t in y of t and 2y of t and y prime t. So y of 0 is equal to c1 plus c2, right? Which is 1, must be 1. And the y prime 0 is c1 minus c2, right? Is equal to, must be 0. Okay. So we got, system of, the linear equations. So then c1 must be what? 1/2. C2 must be what? 1/2. Okay. So finally, we got particular solution to the integral problem, which is yt is 1/2 e to the t plus 1/2 e to the negative t. Okay, and then plus 1/2 t squared e to the t. Okay, well you can simplify this because e to the, I think I'm sorry, 1/2 is kind of common factor of 3 terms. Okay. All right, and then you can combine e to the t and the e to the t is 1. Okay, so do that, then we're gonna get this 1/2 times t squared plus 1 times e to the t plus e to the negative t. Okay, so what yep. Okay, so the e to the negative t, think about the let's uh pre let's predict the behavior solution. So e to the negative t approaches 0, right? As t approaches infinity. And then t squared plus 1 times e to t is increasing function. So this guy uh, approaches infinity, right? Okay, so there is no oscillation because wave function is not involved. Okay, so this is a dominating term. This is dominated. Okay. So now this is example, first example. And then next example is this. Example 2. Okay. So we're gonna see a mass spring system. Okay. So y dou prime plus 2y prime plus 2y is equal to 2 sine t and then plus 3 times cosine t. Okay. All right. And then where the mass is initially at y0 equals 1 with a velocity y prime of 0 equals 2. Okay. I mean, so mass is initially located at y0 equals 1. That means initial position, right? So initial position of the mass is one, object one, and the velocity of the object is 2. Okay, but meter per second. Okay, and then the well, from here we can see the mass is 1, right? Because the coefficient of y dot prime is mass, right? And then 2y prime is the what 2 is a damping constant, right? And then here also 2y in from the last term, the left hand side, the 2 means the spring constant, right? Okay, and then this is external force. All right, so solution. Step 1, pretty much is similar what we did in the previous example. We're gonna find out homogeneous equation. Okay, so find a dyht. Okay, so the associated homogeneous equation. Okay, let's say he. Okay, associated homogeneous equation. It's gonna be y dot prime plus 2y prime plus 2y equals 0, right? Okay, the Ox equation, the Ox equation is going to be r squared plus 2r plus 2 equals 0. Okay, so now then solve it. Let me use the the quadratic formula. Okay, then r going to be what? Going to be negative 2 plus minus square root b squared, 4, which is 4, right? Minus 4ac, which is 8 over 2, right? So, and then simplify the fraction, we're gonna get the negative 2 plus minus, and then 2 times I, right? Over 2, which is the negative 1 plus minus I. Okay. All right. Thus, the alpha is going to be what? So alpha. So since the Ox equation has 2 distinct complex root, right? Complex root. And then we have to find out imaginary part and then real part, saying that alpha is a negative 1 and then beta is a 1. Okay. So alpha means the real part, beta means the imaginary part. Okay. So now then, the general solution yh of t is going to be c1 times e to the alpha t, which is a negative t, times cosine beta t, which is cosine t, right? Okay. And then plus c2 times e to the alpha t times sine beta t. Okay, so that's the general solution of the to the associated homogeneous differential equation. Now, second step, we're gonna find out yp. Okay, so the first one, that's what we use. Okay, we use the method of undetermined coefficient, right? Okay, undetermined coefficient. So then the first one, the form of yp t gonna be what? Yp of t is equal to t to the s power, right? And then polynomial, but here what? You see that in the problem. So the what in the source functions, polynomial function. I mean, this source function is not involved the polynomial function, right? Well, you can say that 2 is a polynomial function with degree 0. You can say that, but anyway, so in a method of undetermined coefficient says that if the source function has a form polynomial times exponential function times and then sine function or cosine function, then the form of the particular solution must be t to the s power times the a m t to the m's power plus a0 and then e to the alpha t and then cosine beta t. Okay, keep in mind this. Here the alpha beta are not the real part and image part of the ox equation, the root of the ox equation. Okay, so here alpha beta from the source function. Keep in mind this. The plus t to the s power and then bm and the t to the m's power plus through the b0 e to the alpha t and then sine beta t. Okay, so now then the what this is t to the s. Let me figure out s later. Okay, and then what? So here m is what degree of the polynomial in the source function. But what's the source function? Let me write down source function right here. So f of t, by the way, so f of t was what? Source function was 2 times sine t and then plus 3 times cosine t. Okay, so what's the degree of the polynomial? 0. Okay, m is 0. So we're gonna get just a0. Okay, and then e to the alpha t. Is there exponential function involved here? Source function? No. Okay, so alpha is what? 0. So we're gonna get 0, right? So right there, 0. So we got just 1 and then cosine and then what's the coefficient t in source function? 1, right? So we got cosine t. Okay, so similarly in second term m is 0, alpha is 0 and then beta is 1. So we got a t to the s power, t to the s power and then b0 and then sine t. Okay, so from here we figure out that what m is 0. Okay, and then alpha is 0 and then beta is 1. Okay, now let's see. Okay, so now we compare to figure out the s. We're gonna compare the 0 1 with what, with the real part, image part of the ox equation, negative 1 and 1. Definitely your alpha plus I beta, I mean negative 1 and 1 are not equal to what, 0 and 1, right? So s must be 0. Okay, so right here, since alpha plus I beta, okay, which is the this one alpha and beta from here 0 and 1. Okay, so it means 0 plus I. Okay, is not a root of the associated auxiliary equation. Okay, so s must be 0. Okay, so what yp gonna be, it's gonna be a0 cosine t, right, plus b0 and sine t. Okay, now we find out a0 b0, a not b not. Okay, then what, we plug in yp into the non-homogeneous differential equation. So we find that y prime and y double prime, right? Y prime going to be minus a naught sine t and then plus b naught and then cosine t, and then yp double prime t is equal to minus a, oh sorry, plus, right? A minus, I'm sorry, y naught cosine, and then minus b naught, the sine t. Okay, this is cosine. All right, so now then yp dot prime plus 2 times yp prime plus 2yp, this is equal to, yeah, so doing just algebra, okay, and then we're gonna get this a naught plus 2b naught, and then cosine t, and then plus b naught minus 2a naught, and the sine t. Okay, sine t. So that must be equal to what? Source function. 3 times cosine t, I mean external force function, okay, plus 2 times sine t. So from here, we can get the what? System of linear equation of a naught and b naught, right? Okay, so a naught plus 2b naught gonna be 2b naught gonna be 3, and then b naught minus 2a naught must be 2. Okay. So then what? Okay, solve the system. Then a naught must be negative 1/5, and then b naught must be 8/5. Okay. So finally, we got the solution of particular solution of the initial problems. So yp t, okay, or yeah, this is equal to negative 1/5. I mean, sorry, this is just a solution of non-homogeneous differential equation. I'm sorry, negative 1/5, and then cosine t, and then plus 8/5, and then sine t. Okay. And then step 3, and then combine yh and yp, right? And then impose the initial condition. So then y of t is equal to yh t plus yp t, right? It's going to be c1 e to the negative t, right? And then cosine t plus c2 times e to negative t, and then sine t. That's the homogeneous, general solution to the associated homogeneous equation, right? So this is the yh, okay? And then plus yp, okay, minus 1/5, and then cosine t plus 8/5, and then sine t, okay? That's going to be yp, right? So now then, to find out C1 and C2, we impose the initial condition, okay? So let's find the y prime first. Y prime t, it's going to be minus, right, C1 e to the negative t, and then cosine t, okay, and then minus C1 e to the negative t, and then sine t, and then minus C2 e to the negative t, sine t, and then plus C2 e to the negative t, and then cosine t, and then plus 1/5 sine t plus 8/5, and then cosine t. Okay, all right. So now and then plug in 0 into t, okay, y of 0, maybe c1 minus 1/5 is equal to 1. Does it make sense? Because look at this, plug in 0 into t, then what? We're gonna get the cosine 0 gonna be what? 1. The sine 0 gonna be 0. Okay, and the e to the 0 is just 1, right? So we're gonna get c1 and then minus 1/5 times 1 plus 8/5 times sine 0, right? You see that? So when t equals 0, we plug in 0 into t. What happened? Cosine 0 gonna be what? 1. Sine 0, 0. Sine 0, 0. Cosine 0 is what? 1. Okay, and then so the e to the 0 is 1. E to 0, 1. Okay, so C1, I mean, what C1 gonna be just left, negative 1/5 left. So we got C1 minus 1/5 equals, must be 1, right? That's why. Because the initial condition was 1. Yeah. So problem says that y0 is 1. The initial position of the object is 1. That's why C1 minus 1/5 is 1. Okay. So what about y prime 0? Y prime 0 gonna be what? Y prime 0. Let's see, cosine 0, 1, and then sine 0, 0. Okay, sine 0, 0. And then cosine 0, 1, sine 0, 0, and the cosine 0, oops, cosine 0 is 1. Okay. Then we're gonna get negative C1. And then all of the exponential term gonna be 1 when t equals 0, right? So when t equals 0. So negative C1 plus C2. Where we get this C2? We get the C2 right there. Okay, negative C1, C2, and then 8 over 5 plus 8 over 5 is equal to 2, right? Okay, so we got the system of the equation for C1 and C2. So C1 is what? 6 over 5, and then C2 is equal to 8 over 5. Okay. So now, let me see. So plug in 6 over 5 and then 8 over 5 into C1 and C2 in a general solution to the non-homogeneous differential equation. You will get the what particular solution up to the integral problems. Okay, so finally, y of t equal to 6 over 5 and the e to the negative t minus 1 over 5 cosine t. Okay, and then plus 8 over 5 e to the negative t, and then plus 8 over 5 sine t. Okay, yeah, I just simplify the particular solution. I mean, yeah, I just plug in C1, C2 into here. Okay, so it's here and here. Okay, and then I just combine these two guys, and I just combine these two guys. Okay, so we got this. All right, that's a solution to the integral problems. Okay, so let me stop here. Okay, and then next video I'm going to cover 4.6. Okay.